Hi everybody, this is part 3 of graphing quadratic equations that are given in general form. Now in parts 1 and 2 we looked at how to rewrite a quadratic equation that's given in general form in what's called the vertex form, and we did that by completing the square. Well, here we want to look at something a little bit different, and what we want to notice is if you have a quadratic equation, you know that because of the symmetry, that if you can draw a line right through the vertex, okay, and it turns out then that your x-intercepts are exactly the same distance on both sides of where your vertex is. Okay, so we know that these x-intercepts are given to us by this quadratic formula that hopefully you have memorized. X is a negative b plus or minus the square root of b squared minus 4ac all over 2a. So what this means is that the coordinates of this x-intercept right here would be a negative b over 2a, and the negative b over 2a is the point right in the middle. And then if I go plus the square root of b squared minus 4ac over 2a, that's this x-intercept. And then if I go to the negative b over 2a, which is here again in the center, the negative b over 2a, and then I go minus the square root of b squared minus 4ac over 2a, that would be this other x-intercept. So the point of that is to realize that you already have this formula memorized, and this part of the formula, the negative b over 2a, is exactly the center of the parabola, and that's where the vertex is at. And so if all you need to do, and a lot of problems, all you really need is the vertex. That's the key point, at least to get a sketch of the graph. That vertex is always where x is equal to a negative b over 2a. And then if you want to find the y-coordinate, you just plug negative b over 2a into the function. So this is another way of getting that all-important vertex point. So suppose I wanted to find the vertex and the x and y intercepts of this function right here. Well, right away I know the vertex, from what I told you above, is going to be negative b over 2a for the x-coordinate, comma, and then f of that negative b over 2a. So let's take my calculator and let's figure out, especially these that have decimals in them, that's going to equal a negative b, so that would be a negative 7.92 divided by the quantity 2 times negative 18.8. All right, so that gives me sort of a nasty decimal, 0.21063. So this is going to be, let me write it out here first of all, negative 7.92 over 2 times a negative 18.8, comma, and then f of whatever that is, we just found it on our calculator, is about 0.210. All right, so this right here is 0.210. So if I plug that value into the function, that's going to be my y-coordinate. All right, so this is going to be 0.210. We'll just round that off. Let's see, did I get it? Yeah, well, let's make it 0.2. Let's just call it 0.21. We'll round to the nearest hundredth there. Okay, comma, and then I want to plug that number in to my function. So when I do that on my calculator, I'll just store that as x, and then I'll just run it through this, the negative 18.8 x squared plus 7.92x plus 6.18. All right, that gives me 7.01 roughly. All right, so this would be my vertex. Now I can also find my x-intercepts. I know my x-intercepts. I can find those by letting y equal 0. So I'll let y be 0. Y is the same as your f of x. So just solve negative 18.8x squared plus 7.92x plus 6.18, and I'm going to go ahead and use my quad program that I have on my graphing calculator here that I've programmed in there. And if you don't have that in, you can find a video on YouTube that I've made for how to program that in. Alright, so my A is a negative 18.8 and my B is 7.92 and my C was 6.18. And so this gives me my x-intercepts about negative 0.40 and about 0.82. And for my work, I'll just say by the quadratic program in graphing calculator. Okay, and then my y-intercept, to find the y-intercept, I just let x equal 0, so that's just the function evaluated at 0, and this is 0 and this is 0, so I'll just get 6.18. Alright, so there's my y-intercept, there's my x-intercepts, there's my vertex. So from those, I could graph those pretty easily, and what I've done below here is I've actually graphed on the graphing calculator the negative 18.8x squared, and it's right here. You can see it opens up, opens downward, I should say, and you can go ahead and find that vertex on your graphing calculator by using the maximum function. So let me show you how you do that. If I wanted to graph, let's go over here to my y equals, and let's put in here negative 18.8x squared plus the 7.92x plus the 6.18. And let me just graph it on my standard window. I'll just graph zoom 6. You'll notice that a negative 18.8, that's going to be really skinny, isn't it? And it's opening downwards. And so I might just change my window here to go between, like, well, as I did in this screen, went from negative 2 over here to about 3, it looks like. Okay, so let me just set my x to go from negative 2 to 3. And that'll give me a picture that looks like this. That looks a little more like the one on the screen here. So I know the vertex at this point, and that vertex is 0.21 and 7.01. Now if I was graphing this by hand, all I'd have to do is go to this point and draw a skinny parabola opening down, right? If I want to verify that on my calculator, I can calculate. So I hit the second button and then calculate, and I want the maximum, right? Because the vertex, because it's opening down, is going to be a maximum. And then I'll give it a left bound, so I'll go over on the left hand side of the maximum, hit enter, and arrow over on the right hand side of the maximum and hit enter, and then give it a guess. Get up here kind of close to the top, and it computed the maximum to be 0.21063, and that's the exact same value that I got right over here when I did the negative b over 2a. And notice that the y coordinate is 7.014, and that's the exact same value I got when I plugged in this value into the function. Alright, and then I could also go ahead and find those x-intercepts if I wanted to. I have a 0 button on my calculator. I could find the 0. So if I do that on my calculator, I'd want to go over on the left hand side of the 0 and hit enter, and then arrow over on the right hand side of the 0 and hit enter, and give it a guess, get kind of close there and hit enter. Notice that's not quite 0, is it? But it is negative 0.40, and that's what we got up here when we did it using the quadratic program that's programmed into our calculator. All right, and you can see that this one here is going to be, what was it, about 0.82. You see that's just a little bit smaller than 1, and so that's reasonable as well. Okay, so I hope you find that helpful.